There we go. Okay, so events at the neuromuscular junction. So the summary of the events is this. This is the summary, and then we'll break it down, okay? So the summary is that we're gonna have electrical activity come down the motor neuron. So we call that an action potential or a nerve impulse. And we'll worry about how that happens when we get to the nervous system. But the electrical activity triggers the release of neurotransmitter, which we know is acetylcholine. And the neurotransmitter crosses the little gap between the neuron and the muscle membrane, and it binds to receptors that cause sodium to go into the cell. And that's going to cause electrical activity of the muscle cell, okay? So what happens at the neuromuscular junction is that the neuron electrical activity causes muscle electrical activity. That's the like really broken down summary of what happens. So when we look at that in more detail, we see that the major step, the big thing that happens is that the acetylcholine is released from the end of the neuron and it diffuses across this cleft, this gap. This gap, because the membranes don't touch, and it goes and binds to these receptors, okay? So again, it's the neuron electrical activity that causes the release of the acetylcholine. And the result of the acetylcholine binding to the receptor is that we're going to get movement of ions, especially sodium. Oh my God, especially sodium. So that's because the receptor for acetylcholine is an ion channel, right? So we're literally opening an ion channel with the neurotransmitter. We're going to get sodium moving in as well as potassium moving out. Because sodium is moving in larger volumes, we're going to get depolarization of the membrane. So the membrane becomes positive on the inside of the muscle cell, whereas it used to be negative. And all we need is enough of that to happen to trigger the voltage-gated sodium channels that are in the muscle cell membrane to open. So once that happens, we're going to see the electrical activity of the muscle cell rapidly change. So it was negative, and then the neurotransmitter hits, and then it becomes very positive. And then, of course, that's going to reverse because this is just a very quick thing. And it reverses because the sodium channels close, and at the same time, there's potassium channels that open. Now, these are triggered to open at the same time that the sodium channels are. So this triggers all of the voltage-gated channels. It's just that the potassium ones take longer to respond. And so once the potassium ones open, now potassium is going to exit the cell, and that's going to cause the charge to become negative again. So we call that part repolarization. And the sodium coming in is depolarization. And then there's a period of time where the cell is not responsive to stimulation again. So we can have acetylcholine being released and the cell isn't going to listen to it because it has to reset itself. So this is during the repolarization because now we have to fix this, right? We have to fix the fact that the sodium came into the cell when we want to keep it out most of the time, and the potassium left, but we like to keep it in most of the time. So we need that sodium potassium pump to get us back to normal, and then it's able to be stimulated again. Does that cover it? So yeah, what happens before cross bridge formation, so it does start with the events at the neuromuscular junction, but it takes one more thing to get us to cross bridge formation. So in order to get to cross bridge formation, the electrical activity that we just described has to result in the release of calcium into the sarcoplasm. So the sarcoplasm is the cytoplasm of the muscle cell, and that's where the myofibrils are. So that's where we need calcium to be. And so the event that happens in between the neuromuscular junction and cross-bridge formation is this excitation, contraction, coupling. So coupling is what we call it when two things join together. So this is joining together the electrical activity at the neuromuscular junction with the contraction cycle, which is the cross-bridge formation. And basically it's just that the T-tubules are also having an action potential, so they depolarize and repolarize too. And because of their intimate relationship with the terminal cisternae of the sarcoplasmic reticulum, which is where the calcium is stored, when the T-tubules depolarize, we open calcium channels in the sarcoplasmic reticulum and we release calcium. And so then we set up the conditions that allow for cross-bridge formation, because calcium, oh, I had that wrong. Calcium binds to troponin. Troponin allows tropomyosin to move off of the myosin binding sites on actin, and now the actins and the myosins are able to bind together, and that is cross-bridge formation. So this is our linking together. So as this is depolarizing, so is this, and that's going to release calcium. So that takes us to the contraction cycle. Okay, good. I'm glad I got it right somewhere. Any questions about the contraction cycle before I pop out of this? Anybody else? You're welcome. Sure. Okay. So let's go to our skeletal muscle lecture. And, ooh, that's joints. And look at different ways to make bone. Okay, so remember that ossification means bone growth. So we know that either way we're making new bone, like brand new bone. So with endochondral ossification, the key is that we're starting by making cartilage. So endo meaning within and chondro meaning cartilage. So we're getting bone made from within cartilage. Most bones in the body are formed like this. And so literally what happens is mesenchymal tissue, the stem cells, they become cartilage making cells, so they become chondroblasts. Chondroblasts make a cartilage bone, and then that cartilage bone actually ossifies, so it becomes mineralized, and then that cartilage dies, and then the osteoclasts come in and dissolve it, and the osteoblasts invade it and make bone and build the bone on this like dead cartilage framework. So that's how most bone is formed, is by starting with a cartilage model and then replacing it with bone. This is the only way to make really good three-dimensional bone shapes, because when you let bone form directly, it kind of just makes sheets. And so when we're trying to make bone directly, that's when we have these mesenchymal stem cells go straight into osteoblasts. Sorry. So now we're not doing a cartilage model. And the cool thing is we can make bone that way, but because it can really only make a sheet, it can't form into different, more complex shapes that way. It can only make flat bones. And so the only bones that use this particular technique, this type of bone formation, are the flat bones in the skull, and for reasons I've never figured out, the clavicles. Okay, so this is much less common, and it's intramembranous, I think, just because like the sheets of mesenchyme that become osteoblasts are probably some sort of membrane, some sort of connective tissue membrane. Any other questions about bone formation, lengthening, thickening, anything like that while we're here? This. All right, what else? Any other questions? Right, yeah, so testing details. So the test is going to be set up so that once you answer a question, you're not going to be able to go back. And then once you start the test, you can't stop it and like pause it and come back later. But if you have issues, like if your internet craps out or you have like a home emergency or anything like that, where like you're taking the test and then you can't finish it, just shoot me an email. I'm going to be watching all my emails, trying to watch really closely, and I can reset it for you. I'm setting it up so that it's basically so that the number of questions I put in is a lot more than what you're going to see. So I'm using a test bank, and each of you is going to get like a unique randomly selected assortment of questions covering all the different topics that we're covering. So if you restart the test, you will be starting with new questions. But that, so yeah, I don't have it set up so that you can take it again or anything like that. There's not a good way to set it up so that you could like stop it and come back to it. But if it did come up, just let me know and I should be able to reset it for you. Yeah, so the quizzes is where I can put tests on Canvas, and I'll be sending an announcement out to make that clear, like with all that basic information, like what I just said. So you'll go into quizzes. I'm gonna have the test released tonight at 8 p.m. and then it'll be available through tomorrow night, so that you have time. If you've been studying and you're ready to go and you want to tackle it tonight, go for it. If you want to tackle it in the morning, if you need a little bit more time, then you can tackle it tomorrow night if you need to as well. But you should be able to see it starting tonight at 8, and you'll go into quizzes and it'll say what exam are we on? Lecture exam, whatever we're on. 2, 2, 3, 2. Whatever it says. Where is it? Oh yeah, 2. There it is. Okay. Yeah, so 2. It'll say lecture exam 2 or exam 2, I guess. They're all lecture exams. And once you click on it, it should take you through it. Mm-hmm. So it'll be 40 multiple choice questions, and then I don't know exactly how many short answer questions there'll be, but it'll be 20 points worth of short answer questions. And then you guys will be able to what's the word? See how you did afterwards. So you'll be able to see the right answers and your answers. On the multiple choice, it should pretty much come up on Wednesday. And then I have to grade the short answer still. Like that's not something the computer can do. So it'll be, it might be a little bit before you get those grades. So your total grade for the exam will have to wait until I do your short answer stuff. Any other questions about the test? Did you not, I posted it. I did if you have particular questions about it, I'm happy to answer them, but I did do a lecture on it, and it should be, you didn't get the video? Let me, 1 second. Was anybody else able to access it? Because it should be there. I posted it on Canvas and it's on YouTube. Did anybody access it or? No? Nobody? Okay. I mean, I can go through it right now and hit on the highlights if you need. But I promise I made a video. Let's see, that was, where would it was under the muscular system video links. Yeah, I just put it under the last one. It's right here. That should be your last little bit. The quiz time, so it'll be 2 hours, and I know it's under quizzes, but it's like a full exam, you know, so yeah, 2 hours to take it should give you enough time. So are you guys okay watching that video, or do you want me to go through that section right now? The highlights, okay. Here. All right, so there we go. Okay, so this is just kind of like the last bits of everything that doesn't really fit into other categories. So it's kind of like other ways to talk about muscle. So, right, this is the one that I didn't do. Okay, so when we talk about muscle, there's other things we talk about other than just, you know, what happens when it contracts. So obviously when it contracts, we talked about that a bunch. But when you're learning the anatomy of it, a lot of times what people learn when they're learning it in more detail than we have time for is how they attach. So origins and insertions are the old school names for that, but we're just going to call them muscle attachments for a lot of different reasons. And then the other thing that we want to know about most of the time is what actually happens when it contracts. So what is the muscle doing? What occurs? And we call that the muscle action. So typically when muscles are attached, they're attaching to bone, and they do it by way of a tendon. So tendons, remember, are the dense, regular connective tissue. And sometimes muscles can attach to other muscles or to skin or whatever, but most of the time they're attaching to bone. And the collagen fibers are continuous from like the connective tissues of the muscle, through the tendon, through the periosteum, through the bone. So everything's really well connected to each other. Now, sometimes the tendon isn't visible, and so we have two different types of attachments based on whether or not we can actually see the tendon. And we know that muscles are going to have at least two attachments, and they're going to cross at least one joint between those attachments, right? So muscles can cross more than one joint, and they can have more than two attachments, but those are the bare minimum. Otherwise, they wouldn't be very useful. So the most common attachment type is called indirect, and indirect is when you can see the tendon. So there's a visible tendon between the muscle belly and the bone, and this is what we typically see. When it's kind of more round, we call it a tendon. When it's a flat sheet of tissue, we call it an aponeurosis. That's basically just a flat tendon. But that's not always the case. So sometimes we can't see the tendon, and then we call it a direct attachment. And so basically there's still connective tissue between the muscle and the bone, but it looks like the muscle comes right off of the bone. So basically the collagen fibers of the epimysium, the outermost layer of connective tissue of the muscle, are actually fused to the periosteum, which is that outer protective connective tissue layer surrounding the bone. So we just like literally skip the middleman. So two types of attachments based on whether or not you can see the connective tissue that's attaching them, okay? So these are some examples. So like this is our biceps guy, our classic example. There's two tendons up here connecting the muscle bellies to the bone, and then there's one down here. And we're crossing the shoulder and the elbow. This is a good example of some direct attachment. This muscle is just like, looks like it's coming right out of your scapula or shoulder blade. And this is a good example of an aponeurosis. So we have a nice flat but visible tendinous attachment. So these are all different words because they're slightly different kinds of attachment, but all of them attach muscle to bone. And then this picture just shows you how we can map those attachments on bone as well, which is just cool. Just wanted to show you that because it's cool. You don't need to know any of those right now. And then that takes us to the action. So this is what they do. And there's different roles that muscle can have based on where it is, what everything's doing. And it's because muscles don't act alone. So muscles are always acting in a group. And that means that different muscles are going to have different positions in the group to do different things. The other thing is that muscles can have different positions depending on the overall action that's occurring. So the three types of actions that you can have are these guys. So prime mover is sort of what we think of typically when we think about what muscles do. Basically, it's the muscle that's providing the force for a particular action. So, you know, we'll go back to an example we like to use because everybody can relate to it, which is, you know, you're flexing your arm at the elbow and your biceps is going to be providing the force for that action. Now, antagonists are muscles that oppose the prime mover, or the agonist. Prime mover. It sounds weird to have a muscle in opposition to the muscle producing force for an action, but there's a couple of reasons for it. One reason is that we want to be able to control whatever that muscle's doing, and so having somebody on the other side doing a little bit less force but the other way lets us smooth out the muscle and have more control over it. And the other reason, like the biggest reason, is because as we talked about when we talked about movement types in the joints lecture, most movements come in pairs, right? Opposing pairs. And so a muscle that opposes the action of a prime mover, like for example, when we flex at the elbow, your triceps is the agonist, but when your triceps, when we want to extend at the elbow, the triceps becomes the prime mover and the biceps becomes the antagonist. So the other reason is because the muscles come in opposing pairs, just like the movements that we can do with them do. So that's kind of the other reason. They're already there. We also have a third type of muscle, and they're assistants. So they're neither the prime mover nor the antagonist. Instead, there's the synergists, and their job is to help the agonist perform the action. So they can do that a couple ways. They can add power to the movement. They can stabilize the joint, so prevent it from moving in ways we don't want it to. They can alter the direction of the action, or they can keep bones or muscles from moving that aren't supposed to move in that particular action. So here's our diagram with that. And it doesn't show you the triceps antagonist, but it's back here, and it's doing its job. So one advantage of this is that muscles their actions can be predicted based on their location. So where they attach across a joint will typically determine their actions, especially when they're being the primary mover. So for example, because flexion and extension occurs in the sagittal plane, so you're either moving anteriorly or you're moving posteriorly, muscles that cross the anterior side of the joint usually produce flexion, although there are some exceptions, and muscles that cross the posterior side of the joint usually produce extension. So here, these examples are with the shoulder. So we have this anteriorly located pectoralis major crosses the anterior aspect of the shoulder joint. When it pulls, it flexes your arm at the shoulder. And then we've got this guy. This is a latissimus dorsi. He's on your back, so it's the posterior aspect of the joint, your shoulder joint. And so when that flexes, or when that contracts, sorry, it's going to extend the arm at the elbow. Now, the big exception here is, of course, that your knee is set up differently than that. So your knee flexors are located posteriorly and your knee extensors are located anteriorly. So the shape and alignment of the joint does come into play here. It's even easier with abduction and adduction. Laterally located muscles abduct limbs, and medially located muscles adduct limbs or other body parts. The other big thing in this section is the muscle shapes based on the arrangement of fascicles. So remember that fascicles are groups of muscle fibers within a muscle organ. And the way that these fascicles are arranged along with the tendons that attach the muscle to the bone determines the shape of the muscle. So we actually have 5 different possible shapes that we can have our muscles in based on this relationship. So there's parallel, fusiform, convergent, pennate, and circular. Parallel is really easy. All the fascicles run parallel to the tendon. And so we typically have this very flat sheet like our abdominal muscles here, or a uniform cylinder. So that one's pretty straightforward. A lot of our muscles are actually fusiform, so they're almost parallel, but there's sort of more muscle fibers than the diameter of the tendon. The tendon diameter is narrower, so it bulges in the middle and then tapers down. So just like smooth muscle fibers are fusiform because they taper at either end and they're bulging in the middle. So we have these fusiform shaped muscles. Convergent is another one. So with a convergent muscle, the fascicles are broadly attached on one side. So we have a lot of attachment here, but all of them come together onto a very small attaching tendon. So it's convergent because when things converge, they literally come together. And this is a very powerful type of muscle. Circular muscles are pretty self-explanatory. The muscle fascicles run in a circle. Now, when we have circular muscle and it contracts, it actually constricts the central opening. And so that allows it to control the movement of things through. And so we call them sphincters. That's the other term for them. Some of those are, in fact, sphincters, controlling the movement of things into and out of the body. But we also have these circular muscles in places like around our eyes and around our mouth. So lots of controlling cavities. The last type is pennate. Pennate means feather-shaped. It's actually the same reason why we call pens and pencils like we do, because, you know, the original writing utensil was often a shaped feather dipped in ink. So with a pennate arrangement, the fascicles come to a central tendon at an angle, and it ends up looking a lot like a feather. We can have different types of pennate because we can have the muscle fascicles all on one side of the central tendon. We can have them on two sides of the central tendon, and we can even have them on more than two sides, in which case we call that a multi-pennate muscle. So that one's probably the most complicated, but those are our five muscle shapes, or muscle types by shape. So there's more than 5 on here because there's 3 pennate examples. The other thing we talk about here is this kind of brief concept of the idea of intrinsic versus extrinsic muscles. So intrinsic muscles are ones where the whole muscle is located on the body part that it moves. Extrinsic muscles attach to the body part that they move, but their other attachment and the muscle belly are located elsewhere. So in the example in this picture, it's talking about muscles of the foot. So if the muscle is on the foot and it moves the foot, it's an intrinsic muscle. But if you have muscles on your leg whose tendons attach on the foot and therefore control the foot, it's an extrinsic muscle. And these are subjective terms because it depends on what body part you're talking about. So you could talk about the entire leg, and all the muscles on the leg would then be intrinsic muscles. And then the muscles like your gluteals and other ones that are attaching, you know, from like your lower back to your leg would be your extrinsic. I did say intrinsic, right? I don't know what I said. So all the muscles on your leg are intrinsic leg muscles. Muscles that just attach and control your leg but are on your trunk are extrinsic. So we can do that with everything. We can talk about, you know, muscles on your head versus the muscles from your neck that can control your head. It's just variable. So this is one of the ways that we talk about muscles in groups, mostly from an anatomical standpoint. And then the last thing on here was just that there's some nice anatomy diagrams that you can access online. So this is actually a link to Grey's Anatomy, which before it was a TV show was actually just a really famous anatomy textbook. And they thought that that TV show should be named that, so they named the character Grey to make it sound clever. So that was that section. But there's a slightly longer, slightly slower version of that on YouTube, and the link is on Canvas. The 3 classes. So, I mean, let's see, what did I even tell you guys you had to know? Where did I put that? Oh, that's in the other lecture. So levers. So the way that we have different lever classes is based on the relationship between, let me get to it, there it is. The relationship between the fulcrum, the effort, and the load. Oh, goodness gracious. No. So all levers work like that. So all levers are going to have obviously a lever, and somewhere there's going to be a fulcrum, somewhere there's going to be effort being applied to the lever, and then the load is where, you know, we're trying to what we're trying to move. And so it turns out that there's basically 3 ways to arrange the effort and the load on the lever around a fulcrum. So you can have the effort on one side and the load on the other, okay? And we call those first class levers. So like these guys are a first class lever because the load is over here, the effort is over here. You can also have both the, whatever. You can also have both the effort and the load on the same side as the fulcrum. And there's 2 ways to do that. So you can have the effort farther from the fulcrum than the load, or you can have the effort closer to the fulcrum than the load. So a second class lever is one where the effort is farther away from the fulcrum, and these guys always have mechanical advantage. And then a third class lever is one where the effort is always closer to the fulcrum than the load. And these guys always have a mechanical disadvantage. So second class levers are always power levers. Third class levers are always speed levers. And then first class levers are the ones where it varies because since they're on either side, it just depends on the relative length of both levers as to whether or not they're there for power or speed. But the whole thing, and like I said, don't worry about that. The whole thing is based on the relationship between the effort, the load, and the fulcrum. Yep, no problem. Anybody else have questions? So like I said, the actual information about the test, I'll post it in an announcement as well. So you don't have to worry if you missed it or didn't write it down or anything. And that includes access to the quiz section because I can just link it through the announcement. So if you're having trouble finding it, it'll be on the announcement too. You'll have until tomorrow night to take the test. So whenever works for you for that, try not to put it off till the last minute, please, because that's never a good idea. And you'll have access to everything afterwards so that you can see what worked and what didn't work and learn from the test. If you have any questions after this, you can also shoot me an email and ask. So anyone else? You have until tomorrow to take it. And I clarify that because once you start it, you have 2 hours to finish it. Whether that's tonight, tomorrow morning, tomorrow afternoon, tomorrow evening. But yes, you have until tomorrow. Yep. All right, if nobody else has questions, let me stop the recording.